Hello guys. Sorry, my voice is whack. I've got flu. We have we have we have an A1502. It's 2015. The bird number it's 80-4924. The description, the issue. It's the device does not power with a power button. So as you guys can see, the description it says power button doesn't work. I'm not sure if the description is visible to you guys. So it will obviously the device, like I said in my previous videos, Apple device is from 2011. Can't start with the charger connected. You do not have to press the power button. So that's why the device can start with a charger connected. However, you cannot first shut down the device with you cannot first shut down the device with a charger with a keyboard. So obviously the guys have already tested with a different keyboard to be sure that it's not an issue of the keyboard. So as you guys know, the first thing we had to do is to take out the back cover to get a holistic idea of exactly what is going on the logic board. The A1502 are Apple lines from 2013 up until 2015. The 2013 and 2014 are very identical boards. However, the 2015 it's different from both. So as you guys can see, all of the keys work except the power button. So when I try to first shut down the device using the power key, it would not respond. So you see, as you guys can see, I keep holding nothing. So the next thing we want to do now is we want to disconnect the battery, take out the logic board to have an idea of exactly what's happening. So I'm using a T5 to take out the screws on the board. All of on an A80-4924, the back of the machine, obviously to take out the back cover you need a P5, a pentalobe screwdriver, and inside you need a Torx T5 to take out almost all of the screws except one, which is you need a Phillips starhead screwdriver, which is what holds which is basically the right hand side that holds your heatsink into the chassis. So we basically disassembling now to take the logic board out to have an idea of exactly why the power button isn't working, even though the keyboard is perfectly in good shape. So well, back to what I was saying, the A1502, it's an Apple 13 inches lines from 2013 up until 2015 when it was discontinued. the first haptic feedback was introduced also in that line of the 13 inches in 2015 on the trackpad. The 2013 and 2014 fits in the same shell. However, the 2015 stands out. The display of 2013 can be used on the 2014 13 inches A1502. However, with 2015 does not share the same display and the same display with 2013 and 2014. The trackpad cable, the trackpad design of a 2015 is also different from a 2013-2014. So now that our logic board is out, we want to put aside the bottom the complete chassis. And now let's now take a visual inspection of the board. So let's open up the board view so you guys can have an idea of what we are dealing with. So that is the board view. I'm trying to clean the section so as to show you guys the board number as well. I'm not sure if you guys can see that. The board number is 80-4924. It's the board number of the device. I hope you guys can see that. So right now we just we'll flip to the other side to SMC on and off L. So that is the signal that your power button will communicate through. And that's gonna take place on pin 5. So first thing first, we want to confirm that indeed we have so we want to use the on and off solder pad to confirm if the board does shut down when you shut the pads. So we basically try to narrow it down exactly to where our issue is. So what we want to do is we want to connect power to the device, and then then just for you guys to have an idea of the device being on, we will be getting a USB device to connect to to the port. So you guys can have an idea as to when the device is on and when it is off. Because with the logic board out, you guys might not know when the device itself, when the board is on or when the board is off. So we will grab a USB drive connected to the device, and you guys will see that the LED on the USB drive. So when the board is on, obviously the LED will show on the drive, and when the board is off, that we can also get to know from the LED on the drive. So just quickly get in the drive. Okay, so here we have a drive. So what we want to do is we want to connect the drive to the board. That will give you guys an idea where when the board is on and when the board is off. What we want to do, okay, this doesn't have an indicator, we need to grab another one. So what we want to do basically is I want to be able to show you guys when the device when the board itself is off, and when it's on, when we short the power button together. So basically, when we short the pads over on and off, so there's an indicator. So right now, when you connect it, as you guys can see, that is the indicator that tells you the device is on. You guys can see that. It tells you guys that the device is on. So what we want to do now is we want to shut the pad and see if we can get it to shut down. So if we can get it to shut down, then we know that at least at the level of the SMC, we do not have an issue because we have communication. So we shut in the pads. And yeah, so when we shut the pads, we were able to turn it off with the pad, and with the same pads we still able to turn it on. So in similitude, that is basically what your keyboard do, or what your keyboard would do. So the signal will travel through pin 5. The signal will travel through pin 5 when you press on the power button. And then we'll go to your SMC underscore on off underscore L. So basically, that signal will remain on 3 volt, 3.3 volt. And then when you press the power button, basically pull that signal down. Then and then obviously then you will the machine will then start. So what we want to do now is we can see that indeed we do not have an issue at the level of the SMC communication. We can power on the machine with SMC underscore on off underscore L. So what we now want to do is we now want to basically do a further inspection. So as you guys can see, there's a bit of a corrosion by the section of by the section of SMC on off, especially R4810. I'm just gonna show you guys. So R4810, it's the initial signal point. R4810. R4810 is the initial signal point from pin 5. So and then it then travels to SMC underscore on and off L, then travels to our SMC. So if because of liquid in that section, there's also most likely being a breaking line. So what we will be doing is first and first we need to clean the section, replace the components, and then we may have to confirm if we have a healthy line by measuring for continuity between R4810 and R4810 and our SMC on and off pad at R5115. Sorry guys, it's the voice, it's so bad. So so at your pin 5, when you press the power button on your keyboard, you travel through the signal travels through R4810, but when your R4810 is destroyed, or when you have a broken pad between R4810 and your SMC on and off to your SMC, what will happen then it will be that the logic board would not be able to the logic board would not be able to tell when you are pressing the power button. So because the signal will not be asserted. So what we want to do is we want to replace the components that you guys can see was damaged by liquid in that section. Replace the component, and then we want to confirm the healthiness of the line. If the line is broken, we will have to run a wire after replacing the component, and after that we should have a fully functional power button. uh, so what we want to do now is we want to first clean out the section, take out the components that were affected, replace them, confirm the healthiness of the line, making sure that the line is there's continuity between R4810 and R5115, so that when the keyboard signal on and off is asserted, when you press on the power key, the signal will travel to your SMC. Because if the signal does not, so if the signal is on, if there is a breaking line, when you press the power button, the machine, the logic board would not be able to tell if the power button if there's been an instruction from the power button. So we want to make sure that that it's addressed. So right now we basically cleaning out the section. We will then redo the parts, and then I get a donor board to get the components from to to make our replacements. So when you're doing repairs, you want to make sure that you have donor boards available. In our case, we have lots of donor board. We really do invest in donor boards because it makes repair really quick and easy. You don't have to wait long to do a particular repair because you don't have the required components. So we try as much as we can to invest in donor boards. So so right now we are trying to clean out the part so that we can have easy replacements of the components. Like I said, guys, it's when you are in this repair field, you want to make sure you invest in donor boards. It makes repair quick and easy. Well, that's we just went to grab a donor board. We will be using the components from the donor board. So the components we will be replacing are going to be the components in that region that were affected by liquid are going to be R 48 55, R 48 56, R 48 58, and then most importantly R 48 10. The R 48 57, R 48 50, 56, and R 48 58 are really not affected uh, because the signals are still very much okay, which is why uh, the because all of the keys on the keyboard are fully functional. But just because we have liquid in that section and we are replacing components in that region, it would be also ideal to just replace everything in the region. So that is what we want to do. We want to replace everything in that region, not just R48 58. Sorry, R4, not just R48 10. So because the signal of SMC on and off L travels through R48 10. The initial and the signal from your pin 5 on the keyboard gets to the pin 2 of R4810, and then travels through the and then it travels through the pin 1 to the rest of the circuitry, where the SMC gets to be aware of the signal being asserted. So right now we want to replace. So we have successfully made ready that section. So now we can transfer the components to it. Now, once this is done, uh, we should be able to now. Um, no, by the way, if this is not done, regardless of how many keyboard you replace on the device on the unit, you will still not have a functioning power button, because what will happen is the SMC will not know when the signal, which is when you press the power button, the SMC will have no idea that that has taken place. So we definitely need to address the issue, otherwise you will not have a functioning power button. So we just making sure the components are properly aligned and put in place. Then the next thing we want to do is we want to confirm the healthiness of the line. We want to make sure that we have continuity between pin 1 of R4810 and the rest of the section of the line. So we want to confirm continuity between pin 1 of R4810 and we can check R45115 to see if we have continuity in that section. Because if we have a breaking line, then that what we are doing now, which is replacing R4810, will really not do us any good, because the signal will remain trapped in that section only and will not be able to travel to the SMC. So we need to confirm that we have continuity. So a multimeter is in continuity mode, and we do not have, is it's open line or L, so we need to run, it means we need to now run a jumper wire across, because right now there is a break in line. So not only was the liquid in that section actually resulted in a breaking line between RU48 10 and RU 51 in 15. Sorry guys. Yeah, flu, it's killing me. Okay, so what we now want to do is we need to create a jumper wire. Even though the components have been replaced, the resistors have been replaced, we now need to run a jumper wire between to to make sure that the line it's complete. Otherwise, we will have the signal being contained in one area but not able to travel to the other area. Yeah, guys. Okay, so what we want to do is we will grab a wire uh, and then try to reveal pad that we will solder it on the wire. The wire is coated, so we will try to just firstly get a measurement, see how much we need, then we can cut accordingly to what we need, so we don't want to have too much of it on our board. So then what we want to do now is we want to scratch out both ends to review, so that, because like I said, the wire is coated, so we want to scratch out both ends of the wire, so as we can then attach one end of it to um, R4810, and then another end to R5115. After that, we should have a healthy line. Uh, so, so with that done, we will be coming to the end of our uh, repair, because we're pretty much done. So once we able to uh, attach the wire, then we will have a healthy line, and uh, uh, then we can now finalize our repair. Obviously, we want to be sure that it works, so I'm also going to test it for you guys to see that yes, indeed, we have a functioning power button. Let's now try to attach the line. Uh, 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 okay, so we just trying to apply solder on both ends of the wire. Uh, I'm just gonna shout out to the Apple repair legend himself, Luis Rossman. Uh, he has done tremendous work uh, for the uh, uh, Apple repair community. He has empowered so many people in the repair industry. He's a person who has inspired me a lot, and he's an amazing teacher. And most of he's learning, his teaching techniques is just unparalleled, and I learned a lot from him, a whole lot from him. Okay, so we touching the wire now, one end to pin one of SMC of R4810, and then the other end to pin one of arrow 5115. Now, after that, we want to clean out this section. So I always make sure I clean out the section that I work on, because it's usually not a good thing, a good scene when you have flux all around your board, because you were there. So you want to make sure you have a clean section on your logic board. So the wire is attached in place. We cleaning out the section, and then we also and by the way, the wire is coated, so there will be no risk of breaching anything with the wire running across the board, because it's not exposed. So what we want to do also is we will so after cleaning it, after cleaning the section we walked, we also want to uh, kind of tack the wire to the board so it doesn't become loose across the board. So right now we just cleaning uh, the section that we walked. Like I said, you always want to make sure that your board is cleaned, and you do not have uh, an ugly looking section of the board that you walked. So Yeah, yes, as you guys can see what we've done. So that is the wire running across the board all the way to our 5115. So the next thing we want to do, I'm just going to show you guys what we have been able to do. So we have just increase the backlight a little bit. Okay, so we had to basically yeah, so run a jumper wire between a 4810 and a 5115. So we want to get to tack the wire in place. We don't want the wire to move around, so just apply a little bit of that. That will just a little bit, just to hold the wire in place. We want to make sure that the wire isn't moving around. Just a little bit, okay. Uh, so after that, we want to then confirm uh, what we have done so far. Okay, so right now, what we want to do is we want to see if uh, just trying to align properly the wire in place. We don't want the wire to just be hanging down. We want to make sure we have uh, uh, a wire that is sitting really nice across the board. Okay, so now that that is done, the next thing we want to do is uh, we want to put the board in the shell to be sure. Let's now see if we have a functioning power key. I mean, at the end of the day, all of the work that we are doing is so if we don't have a functioning power key, then again, we have to find out why. But right now, let us test what we have been able to do. So far, the components that were affected by liquid has been replaced. The broken line has been reattached using a jumper wire. So that's pretty much uh, what we have done. So right now we want to install the logic board in its shell and then see if we have a functioning power key. So initially, like I said to you guys, from I put design from 2011 up until date. So the charger would simulate the on and off signal. So when you connect your charger, uh, provided you have it a properly rated charger, uh, it will simulate your power button and the machine will start without you having to press on the power button. So after we put the board in its shell, what we will be doing to confirm that our repair indeed worked will be for us to use the battery and then power it from the keyboard. Because if we connect a charger, the charger would simulate the power button and we would not need to use the power button. But we'll be doing to confirm that indeed we get the power button working is to power the machine from a battery and not from a charger. In my previous video, I did mention that the power button, even though it's placed on the keyboard, it's not actually part of the keys on the keyboard. So the trackpad is required. Communication will be established when the trackpad itself is connected for your keys. So right now, the battery is connected, and then we want to press on our power button. Let's see if we have haptic feedback. The haptic feedback will tell us that the machine is on. Uh, okay, we have haptic feedback. Let's just wait for an Apple logo. Wait for an Apple logo. That is an Apple logo. So our repair indeed was successful. So yeah, that is it. So what we want to do now is we want to pass the device onto the guys to finalize it. So basically they will do the test. I'm just going to update the tickets real quick. So what they will do is they will do all of the tests that's necessary, and then the device can then go to the owner, and each of these repairs that we do carries um, um, a 1 year warranty. So it's pretty much a very confident type of repair too, because when you buy, for example, when you buy a new logic board, you get a 3 months warranty when you buy a new logic board from Apple. However, the repairs that we do, we tend to give 12 months warranty, because we really want the end user to have a rest of mind in the repair that has been performed. So uh, now we will just put that aside, and the guys will take it off from here. So they will put the device together, do all of the tests that's required, and then the client can be informed about the machine. So that is the end, guys. See you in the next video. Thank you.